All right, so today we're going to start talking about real and imaginary roots of polynomials and what those are. So here are our learning targets. Take a look at these imaginary number cartoons quickly. I'll pause here. All right, what is a root of a polynomial? Simply put, a root is the solution of a polynomial equation. Okay, well, how do we find the solutions? Really, this is going to be where your polynomial function is equal to 0. Okay, so therefore, they're sometimes called the zero of a function. Roots can be real or imaginary. If you use your graphing calculator, you can find real ones. You can have a ballpark or get it exactly, but if they're imaginary, then you need some alternate methods. And that's what we're going to kind of focus on in this unit, is how to find roots. That's really our ultimate goal. Okay, so for it to be a root, it's where the function then, the output would be 0. So how do you know if it's a root? Well, if you're given a root, you can check to see if it is by plugging it in and finding out if you get 0. So that's what we're going to do here. If I plug in 4, it says, is 4 a root of f of x and g of x? I'm going to plug this in and find out. Okay, so that just means I'm going to put it in for x. This is function notation. We did a bunch of this at the beginning of the year, especially with piecewise functions. So I have this, and I'm going to type this in to see what I get. Okay, so I have -5, 4 squared, plus 4 times 4, plus 3. Okay. I get -61. So that is not equal to 0, clearly, right? So f of 4 is -61. Okay. So is this a root? No, because it does not equal 0. So no, because f of 4 equals -61, that's not 0, right? So that's a no. Okay. Well, g of x, how about g of x? Once again, we're going to plug in 4 to find out. So, careful writing this. See, I did that there. Should be plus. Okay. And then -8. All right. So what do I get when I put in 4 into this polynomial? Okay. Well, let's try. I have 4 to the 3rd power minus 6 times 4 squared plus 10 times 4 minus 8. Okay, so this time I do get 0, so that means it's a root. Okay, so g of 4 is equal to 0, and yes, and the reason it is because g of 4 gives me 0. Okay, remember that's what it said right here. When you plug it in, you should get 0 into the polynomial. Okay, generically they just use p of x. So now one other thing that I want to kind of show you on the graphing calculator is, now I typed this function into the calculator. Now if you graph it, you'll notice here I get right at 4 there. You can see it crosses the x-axis. It is equal to 0. I can confirm that by going to the table. You'll see 4, the output is 0 here. Okay, so that's another way. But this only works for real numbers, so I have to have alternate methods besides just my graphing calculator. But this is how we're getting started, okay? Okay, so yes, easiest to just plug it in for now. Okay. All right, one really important thing, a fundamental theorem of algebra, is that for every polynomial function with a degree of 1 or bigger, okay, that has to have exactly the same as the number of same as the degree. So if the polynomial has a degree of 4, then it has to have exactly 4 roots. If it has a degree of 7, then it must have 7 roots. And this is including multiplicities, which we'll talk about here in a moment. But this function right here. Well, what degree is this? Well, we can go back to our notes. Polynomial function, it kind of looks like a W. Remember, these notes you want to have handy. And remember, W ones are fourth degree, right? They're quartic ones. This kind of looks like a W right here. But if you're not sure, the polynomial went, both ends were facing up like this one, right? So that means it's even degree. So that clearly is not a quadratic, so it must be a fourth degree. So it's a fourth degree function, okay? So now that helps. So now I know it's fourth degree. So degree 4. Okay, well, how many roots does that mean it has? Total roots. It has 4 roots. Okay. Now, that's a really important thing. Okay. Now, some of them are going to be real and some of them will not be, and we'll talk about that here in a second. Okay. Now, this is the same thing, and here's a graph. This actually has a degree of 5. This is a weird graph. Now, multiplicities, including multiplicities. So notice here the graph touches -3. It just touches it and then goes back down. Okay. And this one here, it bends around that, okay? Well, if it just touches, then it has a multiplicity that's even. In this case, it would be 2. So what does that mean? It means there are actually -3 is a root twice, okay? What does this mean over here? The root has a multiplicity of 3. That means 0 is a root 3 times. So that can be confusing. We'll talk more about that, but that's just something to be aware, is you can have bends, and we will get into that a little bit more later. But really there are 5 roots here, okay? And they're all real. Okay. Determine the number of roots for each polynomial function and then state if they're real or imaginary. Okay, so roots. How many real and how many imaginary? Oops. Okay, so I think I'm gonna copy that. Okay, so if we look at this first function here, okay, what kind of function is that? To me, that looks like a cubic function, but I want to go back to my notes. Okay, cubic, right? Yeah, cubic looks like this one. It's going the other way, but that's a third degree one. I can be sure because I look here, they're going in opposite ways. So it's one of these two. That means it's an odd degree. So that kind of confirms that it is cubic. All right. So how many roots does this have? It's a cubic function, so that means it has to have 3 roots. Okay. Real roots will be where it crosses the x-axis. So how many times does it cross the x-axis here? Just the once. So real roots, there's just 1 real root. Now I have to have a total of 3. That means I'm missing 2. So the other 2 are imaginary. They will not show up on your graph. So imaginary roots always come in pairs. So they have to have an even number of roots. So I have 1 real and 2 imaginary. That's a total of 3. Okay. Now let's look at this one. This is also an odd degree function. Okay, you can compare this. Go back to your chart. Okay, and it says, you can see they're going in different directions. So this would be odd. Okay, but it looks very similar to this right here. Okay, it's an odd, it's 5th degree. Okay, so now if we look here, we know that there are 5 roots. How many times does this graph cross the x-axis? It looks like 1, 2, 3. 3 times. So that means 2 are imaginary. okay? The real and the imaginary together should give you your total number of roots. Okay, so that's what you're doing with these kinds of problems, okay? Graph it, use your chart to figure out, and then go from there. Okay, now, you know that for it to be a root, when you put it all together, it should equal 0, okay? So if I want to say, what values are going to make this equal 0, the output, right? You would really say, when does this equal 0? Okay, when does this equal 0 and when does this equal 0? Well, let's just look at that first one. When would this be equal to 0? Well, it would be equal to 0 when x is -4, right? Because -4 plus 4 gives you 0. Now, that would make this -4. This would be 0. And this would be -6 if you put in -4. And this would be 1. But if you're multiplying, you know if you're multiplying by 0, that's still going to give you 0. So this would still give me an output of 0. So really, if either of these sections equals 0, then the whole thing is going to be equal to 0, right? So what values for x are going to be equal to 0? Well, -4, +2, and -5. So these would be my roots. So that's helpful because I can work backwards. If I'm given the roots, then I can start with this and write my polynomial function. And that's what we're going to do next. So write a polynomial equation of least degree for each set of roots. Okay? So if the roots are 2, 3, 4i, and -4i, y equals, I'm going to write, if 2 is a root, then I would write x minus 2, because if I put this in here, I should get 0, right, for it to be a root. If 3 is a root, then I'm going to write x minus 3. If 4i is a root, I'm going to write x minus 4i. If -4i is a root, then I'm going to write x plus 4i, the opposite. Okay? Now, I want to write this equation. What is a polynomial that has these as roots, 2, 3, 4i, and -4i? So what you're going to do now is just distribute to figure out what the polynomial is. Okay, when you distribute, you want to do this in pairs. So I'm going to start by multiplying these two together. You also always want to do i's together. So I'm going to multiply x squared, or x minus 2 times x minus 3. Again, I'm just doing this, right? I'm going to distribute like this. So that's what I'm going to do now. So I would get x times x squared, minus 3x, minus 2x, plus 6. So this would give me x squared minus 5x plus 6. So that'll be the first. Now, again, you always want to do this in pairs. Now, if I only had one more, I'd just take this times the next thing. But I've got i's. I want to do these together. So let's see. This would be x squared plus 4ix minus 4ix minus 16, and then I times I is I squared. Okay, now you remember I is equal to the square root of -1, but I squared is equal to -1, so that's going to be helpful. Let's see, these middle terms will cancel out. So I would have x squared minus 16i squared. Well, you know that I squared is -1. Okay, we just said that. So x squared, really, this is the same as x squared plus 16. Okay, now I'm going to erase this and move this up a little bit. Okay, so now what we're going to do is we're going to take this, and we're going to multiply them together. So let's see, we'd get x to the 4th plus 16x squared minus 5x to the 3rd minus 16 times 5 is 80, right? Yeah, minus 80x. All right, and then plus 6x squared. And then that would be 96. Okay, now I want to combine like terms. I see I got like terms here and here. So that would be x to the fourth minus, I'm going to write it in standard form, so highest, work my way down. So this, then this. Now 16 and 6 is going to give me 22. Minus 80x plus 96. Okay, now I'm just going to say this is y equals. This is the polynomial that will give me these 4 roots. Okay, those are the solutions to that polynomial. But this is my answer in the box there. Okay? All right, I hope that makes some sense. Your assignment is Real and Imaginary Roots worksheet. Good luck. Come and see me if you need help.